Hey everybody, this is Mrs. Adiemeyer, and I would like to go over with you guys today how to take a look at the indicator lab results that Ms. Dixon and I are going to be showing you, and we are going to kind of show you how to interpret the data from them because sometimes it can be a little bit weird. So on the presentation, you should have seen, this is for solution A, you should have seen this picture kind of right here. And the first thing we're going to ask you to do is to use the indicator chart that we give you in the presentation to determine the pH range that the indicator is showing. So for instance, this Brome-Kressel green has kind of this weird green color. That green color is going to tell us a certain pH range. And what we want to have you do is record that somewhere on a scrap sheet of paper in a doc, whatever you want to do. And so I'm going to go over with those, and then I'm going to show you how to narrow down your results. So if we look, what we want to do is take a look at each indicator, and then we are going to find that indicator on the chart and take a look at what the color shows us. So the Brome-Kressel green here is definitely green, and if we look at the Flynn indicator chart here, that shows me that my Brome-Kressel green is showing me a solution that has a pH between a 4 and if we talk about rounding up to like a 6. So somewhere maybe between a 4 and a 5 or a 4 and a 6 if I'd write that down. Looking at phenol red here is definitely a yellow color, and in our range, this yellow goes from about a 0 all the way over to about a pH of 7. So on my paper, I'm going to record 0 to 7. For bromethymol blue, it's a yellow color. So on my paper for bromethymol blue, I'm going to record that it's showing me a potential range of a pH of 0 all the way to a pH of 6. And for methyl red, it's got kind of a pinky color. So I'm going to write down that the methyl red indicator is showing me a range of 0 to 4. It's not showing me anything higher than a 4 because then it would be an orange color or a yellow color. Okay, we're going to do the same thing with the thymolphthalein, thymol blue, phenolphthalein, and bromophenol blue. These have tons of tongue twister names, so they're kind of fun to say. So if we look at the data for the thymolphthalein, it has no color, it's colorless, and on our chart here you can see that there's this white area. So from a pH of 0 to about a pH of 9, that would be showing that color. So the thymolphthalein is showing me that my pH is somewhere between a 0 and a 9. Now you say to yourself, how is that particularly useful? It's a pretty big range for your pH that it's showing there, so maybe this isn't the best indicator. Some of them have ranges where their color change shows a really narrow range for their pH, and maybe those are the most helpful. If we look at thymol blue is definitely a yellow color, so that's going to indicate that I have a pH somewhere in between a 3 and an 8. Phenolphthalein has no color, so that indicates the pH of my solution is a 0 to an 8. And bromophenol blue is kind of this weird purpley color, and so that's a pH between a 3 and about a 5. So again, all of these here in these wells are the same solution, just with different indicators in it. So all of these 4 wells and the 4 wells before them have the same pH. It's just that the indicators are showing different ranges. What we need to do now is then take that data and interpret it. So what I did is I put it into kind of a chart like this. The chart for the indicators shows me all of the different possible pHs from a 0 to a 14. And I didn't put 0 in there because I can tell you it's not a pH of 0. So what I did then was I highlighted or bolded the pHs that actually were indicated by that indicator. So if I go back and look, Brome-Kressel green is a 4 or a 5, so I bolded those. Phenol red was 1 through a 6, so I bolded those. Bromethymol blue, 1 through 5, and I went all the way down. And what I want to do is I want to go through all the potential pH units and see if there are any numbers I can eliminate because one of the indicators did not show that value. So if I look at the ones, if we look, this first one is not bolded, and some of these are and some of these aren't. So what that means to me is that it's not possible that my solution is a pH of 1 because otherwise my Brome-Kressel green would have showed that as well. I'll do the same for pH of 2. You can see that some of the pHs of 2 as we go down are not bolded, so I knock that one out. Repeating with 3. Some aren't bold, and this one, look, all of them are bold except for this first one, so Brome-Kressel green here is telling me it's not a pH of 3. Okay? If I look, 4 is bolded all the way way down. So that's a really good candidate that my pH, my solution is going to be a 4. I want to double check 5 because you never know. So if I look here, 5 is bold, 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 not bold, and then it's also not bold all the way down at the bottom for the bromphenol blue. So what that does, and then if I go to the 6, it's not all 6s, not all 7s are bolded. What that tells me is that I have a solution that's probably most likely a pH of 4. And I can confirm, because I'm the one who made it, that it in fact was a pH of 4. So we're going to ask you to do that again with a second mystery solution. It'll have different looking colors and it'll be very different. The answer you're going to find is a whole number. So just make sure that when you do that, you don't get like a pH of 4.35. It's either going to be like a 4, a 2, a 12, whatever. It'll be something firmly in a whole number pH. All right? If you have any questions, make sure you ask. Good luck.